Today we're going to talk about the two different competing theories of the universe, the geocentric theory versus the heliocentric theory. The geocentric theory is the belief that the Earth is at the center of the universe and everything revolves around it, and also that the Earth is stationary and not moving. But that seems kind of crazy, right? I mean, everything we know today tells us something different than that. But think about it for a minute. Does it feel like the Earth is moving? Don't all objects fall toward the Earth? Doesn't it look like the sun moves around the Earth when you look at it during the day? These questions are the reasons that people believed this geocentric theory for so long. It made sense to them, and it went along with what they were observing in their everyday lives. Claudius Ptolemy was the one that first proposed this theory, which became the system of choice for the Roman Empire, followed by the Greeks. So you can see in this picture here, the Earth is at the center of everything, and everything seems to be revolving around it. In the 13th century, it ended up being adopted by the Catholic Church, which is what gave this theory its grip and really allowed it to hold on for so long. Nicholas Copernicus was the first one to challenge this theory. In the early 1500s, he laid out his view of the universe, called the Copernican theory. All planets, including the Earth, revolved around the sun. He was the subject of ridicule until his death because of this theory. Since no one really took his theory seriously, he didn't end up getting in trouble by the Catholic Church in the way that people who later proposed similar theories did. However, even though he wasn't widely believed, his idea kind of still stuck with some important astronomers, and the challenge continued. Along came Tycho Brahe, who was from a privileged background of Danish aristocracy, so he came from a family with money. So he had a great education and the resources necessary to conduct quite a bit of astronomical observations. He had used the finest astronomical instruments of the time and made the highest quality observations that had happened during that time. But unfortunately, he couldn't let go of the geocentric model. So he used all of his observations to try and support the geocentric model of the universe. He came up with this hybrid model that had the Earth at the center, but all of the other planets orbiting the sun. But then Tycho Brahe died, but his assistant carried on his work, Johann Kepler. Johann Kepler published a work called Astronomia Nova in 1609, and this contained his first two laws of planetary motion. One, that planets move in elliptical orbits around the sun, so notice that already that is challenging the geocentric view because this says that all planets, including the Earth, orbit around the sun. And then also that planets speed up when they're closer to the sun. And Johann Kepler was actually Tycho Brahe's assistant. And there's kind of an interesting story there because when Brahe died, Kepler and Brahe's family fought over all of Brahe's instruments and all of his observations. And luckily, Kepler won the case in getting all of his observations, but the family got all of the expensive equipment. So Kepler was able to take these observations that he helped Brahe to make and use them to form some of his theories. And these theories of planetary motion are theories that we still use today. And Kepler was coming up with these observations around the same time as this guy, Galileo Galilei, was using the telescope to make some important discoveries. And a lot of people mistakenly think that Galileo invented the telescope when he did not. He actually used what was called the spyglass then, which was used in navigation and on ships, and he pointed it up towards the heavens for the first time. So while he didn't invent it, he was the first one to point it up to the sky and make astronomical observations with it. And he made many important observations. One was that Venus had phases, that Jupiter had 4 moons that orbited it, that the sun and moon were not perfect. And these observations helped prove the heliocentric theory that the sun is at the center of our solar system. He published his findings, and this made the Catholic Church very upset because remember, they had adopted the geocentric theory as part of their doctrine. He was forced to repent and spent the rest of his life under house arrest. So here are some of his observations. These are his actual drawings. This shows you up here, it shows you Saturn and what he observed as the rings there, and then also the different phases of Venus. And here is a picture of Jupiter with the, you can see the little starry things there are the moons orbiting Jupiter, and you can see how they change position each night. And then also he took some detailed observations of the moon and saw that the moon was not a perfect sphere, but it was a cratered had highlands and lowlands, and he was the first one to discover that. And now we're going to watch a little brain pop on Galileo's life.
Please don't sneak up on me. Dear Tim and Moby, who was Galileo? From Yumi. Galileo Galilei was an Italian astronomer and physicist. His discoveries with the new invention of the telescope changed our understanding of the universe. And his experiments in physics overturned beliefs that had been held for thousands of years. He was born in 1564 in Pisa, Italy. At 25, he became a professor of mathematics at the University of Pisa. Galileo had his own ideas about how the universe worked, and he taught theories that contradicted those of Aristotle. Well, back then, pretty much all of physics was based on the ideas of Aristotle, a major Greek philosopher from the 4th century BCE. Aristotle said that heavier objects would fall faster than light ones. Galileo argued that the speed at which objects fell to the ground was constant. But to scientists in Galileo's time, anything that went against Aristotle's ideas was suspect. That university did not renew Galileo's contract, so he moved on to teach at the University of Padua, near Venice. In 1609, after hearing stories about the invention of a telescope in Holland, Galileo built one of his own and turned it toward the stars. In early 1610, he published his findings in a book called The Starry Messenger. He reported that there were mountains and valleys on the moon, that 4 moons revolved around the planet Jupiter, and that the Milky Way is made up of individual stars. Yeah, well, Jupiter has way more than 4 moons, but Galileo's telescope just wasn't very strong. These were huge findings, though, and Galileo was appointed as court mathematician in Florence. A few years later, in a paper on sunspots, Galileo wrote that he supported Copernicus' theory of the solar system. Nicholas Copernicus was a Polish astronomer who believed that the Earth and other planets revolved around the Sun. This contradicted Aristotle, who believed everything revolved around the Earth. Not to mention the Catholic Church, which also put the Earth at the center of the universe. When Galileo wrote a pro-Copernicus work called Dialogue on the Two Chief World Systems, the Church took action. Galileo stood trial in Rome in 1633, where a court forced him to say that Copernicus was wrong. They also confined him to his own house for the rest of his life, and the sentence against him was read publicly at every Italian university. While under house arrest, Galileo wrote another major work on the motion of objects, which would later influence Isaac Newton's theory of gravity. Of course, after Galileo's death, most of his ideas were proven correct, including his support of Copernicus' solar system. But Galileo's biggest contribution to science may have been his reliance on the scientific method instead of on abstract theory. He used observations and experiments instead of philosophy and thought. In doing this, he was able to get a more accurate picture of the world than folks who just believed what they wanted to. Hey, let me see what you're looking at. Huh. There's something kind of weird about that.
So finally, people started to listen to reason. It took a while for Galileo's ideas to become widespread, and then along came Isaac Newton, who published the philosophy of natural mathematics. And he laid out the universal gravitation and laws of motion. And this was the first time where there was actually someone to explain the physics behind the motion that Galileo was observing. And so he provided the how behind the heliocentric theory, and this was really key in getting it to be widely accepted. So that's it for our PowerPoint on the geocentric and heliocentric theories.